Welcome back to the last session on arithmetic progression. So this is exercise 4. There are 5 problems. So let's solve the first problem. Given an arithmetic progression 121, 117, 113, we need to find the first term which is negative. Right? So therefore, which term would be negative? So we need to find an, the first term which would be negative. So here a is 121, which is the first term, and d is 117 minus 121, which is minus 4. So I need to find the value of an, which would be negative. So an equals a, which is 121, plus n minus 1 into d, which is minus 4. So we have 121 plus 4 minus 4n. So that gives me 125 minus 4n. So this is an. So this is a generalized expression of an. So we need to find the value of n such that the value is just less than 0. So I need to find the first value of the arithmetic progression which is less than 0. So 125 minus 4n must be less than 0. So 125 must be less than 4n, or 125 by 4 is just less than n. So 125 by 4 gives me a value 31.25. Right? So the value of n such that the arithmetic progression would give me the first negative value would be 32. So for n equal to 32, I get the first negative value. Next, problem 2. The sum of the third and the seventh term, that is a3 plus a7, is 6. And the product of the third and the seventh term is 8. So we have a3 into a7 is 8. So we need to find the value, we need to find the sum up to the 16th term. So we know that a3 is a plus n minus 1, 3 minus 1 into d, which is 2d. And similarly a7 is a plus n minus 1, 7 minus 1, which is 6d. And we also have the multiplication which gives us a value 8. So given in the problem a3 plus a7 is 6. So therefore let me add these two. So we get 2a plus 2 plus 6 is 8d equals 6, or a plus 4d equals 3. So by dividing the entire equation by 2. So now what is a? A is 3 minus 4d. Okay, so now let me substitute the value of a in a3 into a7. So what is a3 into a7? a3 is a plus 2d, and then we have a7 is a plus 6d, and when I multiply these two I get the value as 8. So the value is equal to 8. So now let me substitute for a in this expression. So a equals 3 minus 4d. So we have 3 minus 4d plus 2d into 3 minus 4d plus 6d equals 8. So we have 3 minus 2d, and then we have 3 plus 2d equals 8. So now let me multiply the two expressions. So we get 9, and then we have plus 6d minus 6d, and then we have minus 4d square equals 8. So I cancel these two. So we have 9 minus 8 equals 4d square, or 1 by 4 equals d square, or d equals plus minus 1 by 2. So we have two values of d. So d can either be plus half or it can be minus half. So now let's try to find the value of S16 with these two values. Now if d equals, so the first case, if d equals plus half, substituting the value of d here in this expression for a equals 3 minus 4 into d, which is 1 by 2. So a equals 3 minus 2, which is 1. So if a is equal to 1, what is S16? S16 is n by 2, which is 16 by 2 into 2a, 2 into 1, plus n minus 1, 16 minus 1 is 15 into d, which is 1 by 2. So here we get the value as 76. So if d is half, a is 1, and then the value of S16 is 76. Now we have another case where d equals minus half. In that case, a would be 3 minus 4 into minus 1 by 2. So that gives me 3 plus 2, which is 5. So if a is equal to 5 and d equals minus half, we get S16 equals 16 by 2 into 2 into a, which is 2 into 5, plus 15 into minus half. So here the value of S16 is 20. In the third problem, there is a ladder given and the rungs reduce in their length as we proceed higher. The lowest rung is of length 45 centimeters and the highest rung is of length 25 centimeters. It is also been given that a rung is placed at a distance of 25 centimeters and the gap between the lowest and the topmost rung is 2.5 meters. So we need to find the total amount of wood which is required to build these rungs. So how many rungs would be there? So the total gap is 250 centimeters. 2.5 meters is 250 centimeters divided by 25, because there is a rung at a distance of every 25 centimeters plus 1. Now why is it plus 1? If I have two rungs, the distance is 25 centimeters. Okay, so how many rungs would be there? So the distance divided by this distance, so 25 by 25 would give me 1. So I have an extra rung here, so I need to add plus 1 to find out the total number of rungs present. So the total number of rungs present would be 10 plus 1, which is 11. So now we need to find S11. So we know that S11 is n by 2 into a plus n. So n is 11 by 2, a is 45 plus L is 25, right? So that gives me 11 into 35, which gives me 285 centimeters. It's a very simple problem here. The fourth problem, there are houses which are numbered from 1 to 49 consecutively. So there are 49 houses and each house is given a number and they are in order. Now show that there is a value x such that, so there is a value of x such that the sum of the number of houses preceding x is the sum of the house numbers following it. So I have x here. So some house number is x. So it is being given that if I take the sum of all the numbers from 1 to x minus 1, that is s of x minus 1, that would be equal to the sum of all the numbers further from x. So that would be s49 minus sx, right? So the sum of all the numbers of houses preceding x would be s of x minus 1. would be equal to the sum of all the numbers following it, which is S49, because 49 is the last number, minus Sx. So let us consider the sum of the x house number. So that is going to be, so this is x, so the house number is x. So I have the value of n is x by 2 into 2a, a is 1 and d also is 1, 2a plus n minus 1, instead of n I have x minus 1 into d, which is 1. So we have x by 2 into 2 plus x minus 1, so we get x plus 1. So Sx is x by 2 into x plus 1. So similarly, what is S of x minus 1? So that is replace x by x minus 1, so I get x minus 1 by 2 into x. So x minus 1 plus 1, so I get x. So now let's try to find the value of S49. So S49 is 49 by 2 into a plus l, that is 1 plus 49. So this is the value here. So this gives me a value 1225. So we have all the values, we have S of x, we have S of x minus 1 and we have S49. So let us substitute all these three in this equation and we equate the corresponding terms. So S of x minus 1 is x into x minus 1 by 2, and that is equal to S49, which is 1225 minus S of x, which is x into x plus 1 by 2. So let me take this to LHS. So I get x square minus x. So if I take this to LHS, I get plus x square plus x, the whole thing by 2, equals 1225. So x and x gets cancelled. So this is 2x squared by 2, 2 gets cancelled. So x square equals 1225, or this implies x is plus or minus root of 1225. So 1225 square root is 35. So we get plus minus 35. So since the value of x cannot be negative, x is 35. So there is a terrace at the football ground with 15 such steps, and we need to find the total volume. So since there are 15 steps, we find that this distance is 50 meters. So this is 50 meters. And we find that the height is 1 by 4 meters and the width is 1 by 2 meters. So the volume of the first step, so the volume of this first step would be, so volume of first step is nothing but equal to 1 by 4 into 1 by 2 into 50. So that gives me a value 25 by 4. So now let me consider the volume of the second step. So here what happens at every step, we find that the width increases by 1 by 2. So volume of the second step is again 1 by 4 into, so the width increases by 1 by 2. So 1 by 2 plus 1 by 2 is 1 into 50. So therefore we get 25 by 2. The volume of the third step, so this is second, the third step is 1 by 4 into, so again the width increases by half, 1 by 2. So I have 3 by 2 into 50. So this in turn gives us 75. So the volume of the third step, so here we have 25 into 3 is 75 by 4. And so on. So now we get the volume of the first step, second step, third step and so on. So we have found out the value of A. So A is 25 by 4, and we need to find the value of D. D is 25 by 2 here minus 25 by 4, right? So this is 50 by 4. So I can write the value of D, that is the second one, as 50 by 4 minus 25 by 4, which is 25 by 4 itself. So the value of D is 25 by 4, and we know that there are 15 steps. So S15 is 15 by 2 into A, 2 into 25 by 4 plus n minus 1, 15 minus 1, which is 14, into D, which is 25 by 4. Right? So when I calculate the value, I get it as 750 meter cube. So the entire volume of this terrace on the football ground is 750 meter cube. So we find the volume of the first step, second step, third step, and so on. Find the difference D, and we also get the value of A, and we use this expression to find the value of the total volume required for the terrace, having 50 number of steps being placed on the football ground. Right. So with this we have completed all the exercises given in the unit Arithmetic Progressions. So I hope you have found the video informative. Keep solving problems, more and more problems, so that it becomes easier for you to solve them in the examination. And thanks for watching. Do like, share and subscribe, and please press the bell icon to get notifications of further uploads.